Hello, welcome back to Algebra 1. This is a video over Unit 9, and we're going to talk about Section 5. So this is going to be a section called Solving Quadratic Equations Using the Quadratic Formula, okay? And so what I want to do, I'm not going to show you how we get the quadratic formula yet, but what I'm going to do is show you how to use the quadratic formula, okay? All of these equations in this function are given by, or in the form of ax squared plus bx plus c, okay? Where a, b, and c are the coefficients of the function, okay? And so what we want to do is we want to identify what those coefficients are, and we use this thing called the quadratic formula. So this right here is your quadratic formula, all right? And there is an easy way to remember it. If we think of the song Pop Goes the Weasel, and that would be x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and so what we do is we get those numbers for a, b, and c, and we plug those into the quadratic formula, and we do the math. Okay, so what we want to do, and that was, okay, so this is the same question here. Okay, use the quadratic formula to find the solutions of the quadratic equation x squared minus 4x minus 5 equals 0. Okay, so what we're going to do is we're going to have those values. So let's find out our a value, our b value, and our c value. Okay, my a value is always in front of my x squared, and that value is 1. My b value is in front of my x, and that's negative 4. My c value is my last value, which is negative 5. Okay? So what I want to do is plug those numbers into my quadratic formula here. Okay? So I'm going to write them down over here as well so I can see them. A equals 1, b equals negative 4, and c is equal to negative 5. Okay? So I'm going to plug those in, and I'm going to plug them in just how I see them. So I've got x is equal to opposite b. So if I've got opposite b here, I want to take the opposite of what I have, which is negative 4. So the opposite of negative 4 would be positive 4, okay? Plus or minus the square root of negative 4 squared minus 4 times a, which is 1, times c, which is negative 5. And this is all over 2 times a, which is just 2 times 1. Okay? Now what we need to do is we need to do the math. All right? So from here, all right, what I want to do, we want to think about our order of operations. Okay? First thing I want to do is evaluate what is under my radical symbol here. So x is going to equal positive 4 plus or minus the square root of negative 4 quantity squared. So negative 4 times negative 4 is positive 16. Then I want to do minus. So I've got negative 4 times 1 times negative 5, okay? Now, the minus 4ac, this 4 is always going to be negative, okay? So negative 4 times 1 is negative 4, times negative 5 is going to give me a positive 20. And then this is all going to be over 2, all right? So now the next step that I want to do is continue to work under my radical. So I've got x is equal to 4 plus or minus the square root of 16 plus 20, which is going to be 36, over 2. Okay? Now, what I can do here is continue to simplify it. So I've got that x equals 4 plus or minus. Now I can take the square root of 36, which gives me 6, and then divide it by 2. All right? So now that I have that, I've got now I've got two equations. Okay, I've got x is equal to 4 plus 6 over 2, and I've got that x is equal to 4 minus 6 over 2. So 4 plus 6 is going to give me 10 over 2. 4 minus 6 is going to give me negative 2 over 2. So here I've got that x is equal to positive 5 and x is equal to 1. Okay? So this is just another way for us to solve quadratics. Okay? Remember, we could solve them by factoring, we could solve them by completing the square, but now we have this third method called using the quadratic formula. Okay? All right, so now comparing the solutions to the quadratic formula. So we did this, and this is negative 1. My bad. Okay? And so let's take a look. All right, so we did this using this method. We got x equals negative 1 and x equals 5. Now let's go back and let's just factor this and let's see what we get. Okay? So if I factor this, I get two numbers that multiply to negative 5 and add to negative 4. So I'm going to do x minus 5 times x plus 1. All right? So if we factor that, that's what we get. Now remember, if we factor it, we just set each of our factors equal to 0. All right? So I'm going to add 5 to both sides. So we get that x is equal to 5. Subtract 1 from both sides, and I get that x is equal to negative 1. All right? We get the same answers. One is infinitely faster than the other one, requires a ton of less work. However, sometimes not every function is factorable. And we found that out in the last couple sections where you can't factor it, so we have to use completing the square, okay? And that's what was nice about completing the square. So if you can't factor it, go ahead and factor it and solve. If you can't, use the quadratic formula, okay? All right, so now let's take a look at the next one. It says solving for zeros of the quadratic function. Same thing as finding the solutions to the quadratic function, okay? So let's do this. Let's label our a, our b, and our c. So a is the number in front of x squared, which is 1. B is equal to 5, and c is equal to 3. Now here's the thing. This equation here cannot be factored. Okay? There's no two numbers that multiply to 3 and add to 5. So we can't factor this equation. So the only way for us to solve this is by using either completing the square or quadratic formula. Okay? And quadratic formula and completing the square are actually the same thing. We'll talk about that later, but not right now. So let's plug this into the quadratic formula. Okay? And let's solve. So x is equal to opposite b, so opposite 5, plus or minus the square root of 5 squared minus 4 times 1 times 3. And then all over 2a, so 2 times 1. Okay? So x is equal to, all right, so let's do the math underneath our square root first. That's the first step we want to do. So I'm going to do negative 5 plus or minus the square root 5 squared, which is going to give me 25, minus 4 times 1 is 4, times 3 is 12. So because I have a negative number here multiplied by two positive numbers, the sign here is going to stay negative. So we're going to have minus 12, and then this is all over 2. Now, we want to do this. So 25 minus 12 gives us 13. All over 2. All right? So I've got negative 5 plus or minus the square root of 13 all over 2. This I can't simplify any further. I can't evaluate the square root of 13. So I just want to leave it as is. So on this, all right, you could leave your answer like this. All right? That would be fine for me. A lot of times will want your answer as two different equations, and that would be negative 5 plus the square root of 13 over 2, and x would equal negative 5 minus the square root of 13 over 2. And those would be our two answers, okay? Okay, so on the last one, we already went through and we solved this quadratic and we got these values for x. Now, these are some weird values that we get for x. And what I want to do is, verify that these, in fact, are the zeros. Okay, they're the same thing as solutions to the quadratic. And, what I want to do is just verify that these are, in fact, the values that we should get. Now, when you graph this function, okay, you get these values. You get that x is equal to negative 4.303, and you get that x is equal to negative 0.697, okay? Now, it's pretty easy to identify these, but when you have the decimals, you have to go into Desmos and check these values as well. So I'm going to go ahead and plug these into Desmos real quick, just to verify to see what we get. All right, so I just typed these in just how I see them, into Desmos, and then it will evaluate those values for me, and it verifies that when I graph this original function, okay, in Desmos, to find where it crosses the x-axis is the same thing as what we found algebraically. So you need to be able to do both. You need to be able to show me how to arrive at these answers, but then also know how to check to see if you've gotten the right answers. Okay, it's why we use the graphs. Okay, we don't use those to just answer the questions. All right. Okay, let's talk about what the quadratic formula tells us. We have this thing called a discriminant. Okay, and let's write this down over here, that the discriminant, all right, is what is the b squared minus 4ac. It's also the part under the radical. Okay, and what this does, the discriminant tells us the types of solutions that we have, okay? And so if we have a discriminant, when the discriminant, and let's do this, is when it says this, that the discriminant b squared minus 4ac, the part that's under the square root, when you get a positive number, when it's greater than 0, that's what that means, that this is positive, okay? So positive, okay? Then when you have a positive value, you have two real numbered solutions, okay? And then that means that your graph crosses the x-axis twice, okay? When you have a discriminant that is equal to 0, okay, so the discriminant is equal to 0, okay, then you have one real numbered solution and the graph is only going to cross the x-intercept once. Okay, you also have an option where your discriminant is negative, okay, and when it's negative, then you have 0 real numbered solutions, so you don't have any x-intercepts, okay? So, all right, so let's do the next couple problems. Let's do at least this one. Solve for the zeros of this function. Now, the first thing I want to do is write this in standard form, okay? And because I don't like the way it's labeled right now, I want to make sure my x squared term is first. So I'm going to write out negative 3x squared minus 6x plus 1, okay? And we also want to set this equal to 0, okay? Because what we're doing is we're solving for x when the y value is 0, seeing where it crosses the x-axis, okay? So let's identify our a, our b, and our c values. A is going to be negative 3. B is going to be negative 6. C is going to equal 1, okay? So let's plug this into the quadratic formula. So I've got x is equal to opposite b, so opposite negative 6 is positive 6, plus or minus the square root of b squared, so I'm going to do negative 6 squared, minus 4 times a, which is negative 3, times c, which is 1, okay? And that's all over 2a, so 2 times negative 3, okay? So what I want to look at real quick is this discriminant, okay, and talk about this, all right? So when we're doing this, all right, I'm going to do x is equal to 6 plus or minus the square root. The b squared part, if I do negative 6 squared, that's going to be a positive 36, always, okay? And then when I have a negative 4 times a negative 3, all right, it's going to become a plus 12. So plus 12 all over negative 6, okay? Now, 36 plus 12 is going to give me 48, so x is equal to 6 plus or minus the square root of 48. Now, because this is positive, okay, because my value under the square root is positive, all right, what that's going to tell me is that I have 2 real numbered solutions, okay? So we can continue working on this. If this was negative, then we could kind of just stop here and say that we have no real numbered solutions, okay? But let's go ahead and continue this and simplify. So over here, I've got, let me split up the square root of 48 into the square root of 16 times the square root of 3 all over negative 6. So then we're going to get that x is equal to 6 plus or minus 4 times the square root of 3 all over negative 6. Now what I'm going to end up getting here is all these can divide out, and let's simplify them by a factor of 2. All these can divide by a factor of 2, so I'm going to divide this by 2, so I'll get 3. Divide by 2, I'll get 2. Divide by 2, I'll get 3. All right, so what we can get here is then 3 plus or minus 2 square root of 3 all over negative 6, okay? So that's our answer, all right? Make sure that when we do this, we want to, write it as 2 different problems. So I've got 3 plus 2 square root of 3 over negative 6. And then I've got that x is equal to 3 minus 2 square root of 3 all over negative 6, okay? And those negatives can kind of, play some tricks on you if they're in the denominator, but, we can look at that as that comes, okay? Let's take a look at this next one. And this is kind of written in backwards form. And let's write this in standard form like we did on the last one. We want our x squared term to go first. Minus 4x plus 8 is equal to 0, okay? So with that, let's write out our a, which is 1, our b is negative 4, and our c value is 8. Okay, our discriminant, let's find the discriminant real quick. B squared minus 4ac, just to see what kind of solutions we have. And let's write this out as negative 4 squared minus 4 times 1 times 8. All right, so what I'm going to get here, negative 4 squared is 16 minus 4 times 1 is 4 times 8 is going to be 32. That's going to become a minus 32. So 16 minus 32 gives us negative 16. Because the discriminant is negative, okay, then what we can do is we can just automatically say that there are no real solutions, okay? Now, this one, you would want to plug it into the quadratic formula to determine that, but this is the value that we get, okay? So that's what we got. All right, let's take a look at this next one, 4x squared minus 4x plus 1. This is our last one. So let's write out our a value is 4, our b value is negative 4, and our c value is 1. Okay, let's plug it into the quadratic formula here, and let's solve. Okay, so we get that x is equal to opposite 4, so 4 plus or minus the square root of negative 4 squared minus 4 times 4 times 1. Okay, and then this is all going to be over 2 times 4. So look at what we get here, okay? We get x is equal to 4 plus or minus the square root. All right, let's do negative 4 squared, which is 16, minus 16 all over 8, okay? So at that point, when we evaluate what's underneath our radical, look what we get. All right, so 4 plus or minus the square root of 0 all over 8. So notice that our discriminant value is 0. That means we will have one solution. Okay, so at this point, what you have is you have that x is going to equal 4 plus or minus 0. That's just going to be 4 in my numerator over 8. And then this is going to simplify to 1/2. All right, and that's my value for x. Let's go ahead and graph this one real quick just to see what we get. All right, so now that we've graphed this, okay, what we see is that this graph only crosses the x-axis once, okay? And so there is my solution as 1/2, which is the same thing as 0.5. So that's all I got. Hope you enjoyed this video. Hope you enjoyed this class. And we'll talk to you soon. See you later. Bye!